Without further ado, let's welcome Michael, our Star Wars geek.
That's perfect.
Uh-huh.
Thanks, Julie. Appreciate it. All right. So hello, everyone. So as we get started, I just want everyone to be aware. One, we're recording this presentation so that Julie and the library can share this recording on their public channels to kind of share this information with other people who might not have been able to attend tonight. Second, in the event that there is a Zoom bomb tonight, we have a bad actor join the call. I'm just going to close the call right away, and then we will reschedule this event for another night. But knock on wood, that won't happen. We'll progress as planned. All right, let's. Oh, and there's going to be lots of Star Wars memes and inside jokes throughout this presentation. So hopefully everyone here is familiar with the source material. All right, let's get started. So welcome everyone to the science behind Star Wars. I'm Michael Stellfox, NASA Solar System Ambassador. This is presented by the Evergreen Park Library and the NASA Jet Propulsion Lab's Solar System Ambassador Program. Now, these presentations are generally more fun the more audience participation there is. So general rules, please mute your microphone, but when you're not speaking. But that being said, anytime you have a question or a comment or something, please feel free to unmute and ask those questions. All questions are welcome. The more, the merrier. And if you're uncomfortable unmuting your mic, also you can type it in the chat. I'll check that kind of periodically at the end of each section to see if we have any questions. So please bring on the questions. This presentation will go, I'm anticipating it'll go about 45 minutes. If it goes long, it won't go longer than an hour. All right, so here's our agenda. First, I'll do a little overview of the Solar System Ambassador Program. Then I'll do an introduction to myself. And then we have 3 topics we'll be tackling tonight that are all kind of like space-related Star Wars topics. Planetary possibilities, and then Death Star physics. All right, let's jump into it. So the Solar System Ambassador Program, let me start by ripping off the Band-Aid that I'm a NASA volunteer. I am not a NASA scientist. So the Solar System Ambassador Program is a volunteer program where volunteers such as myself have like weekly calls with NASA mission specialists, scientists, engineers, etc., to discuss their missions and discoveries. And then solar system ambassadors like myself, we synthesize that information and present it out to our communities. So unfortunately for the math aficionados on the call, we won't get too deep into any like equations or hard math here, but there will be a ton of Star Wars. All right. So the SSA program it started in 1997. We have a little over 1,000 ambassadors now across all 50 US states and Puerto Rico. And to date, we have engaged over 10 million, almost 11 million people. So we do about 4,000 events annually. Of course, that's changed a little bit with COVID, but that's kind of where we're at as a program. All right, a little bit about me. So obviously, I'm a NASA Solar System Ambassador. Here's a picture of me doing another program. I for a little over 3 years, I developed guest experiences for the Adler Planetarium here in Chicago. I built like events and exhibits for the planetarium, and I currently work in 3D and AR experiences. Really, it's mostly for e-commerce, but the technology that my company has been used by Hollywood studios to create special effects for like liquid and smoke and things, including in Star Wars: The Last Jedi, which is pretty cool. Here's a picture of myself in kindergarten. I'm on the left. I'm a Jawa with my sister Patty, my brother Daniel, and my dad Tim. And here I am a few years later at Disney World meeting, hopefully not my father on the left, and my friend Kevin's wedding there on the right. Tonight I will also have a co-presenter. So it looks like Chris was just able to join the call. Let me see if we can get him off of mute. He's going to be my co-pilot tonight. And Chris, if you can unmute, I'll let you introduce yourself.
Hey, how's it going, everyone? It's Chris. I am also a self-proclaimed Star Wars geek. Been in love with Star Wars since day one. Me and Mike went to high school together. We went to college together, and we both like Star Wars probably more than anybody else we know, which is why I'm on this Zoom meeting here. I live in California now. I'm in the U.S. Air Force active duty. You guys see a picture of me holding my sweet little daughter, Alana. Fun fact, she's named after a Star Wars character from a Star Wars book, so that's a nerd moment. And yeah, I've read a bunch of books, a bunch of the comics, so I'm not gonna say I'm an expert, but I'm pretty close to an expert.
I'll jump in there for you, Chris. And Chris is definitely an expert. He's read over 50 Star Wars books. He's read even more comics than that on top of that. And I definitely made up that last bullet point that he has a Star Wars shirt for every day of the year, but he's probably pretty close to it. How many would you say that you have, Chris?
A lot, probably about 40.
That's incredible. And Chris also has a voice made for radio, which makes him great for doing internet calls. So, all right, let's keep moving. Oh, and I stole this from your Instagram. So the Star Wars shirt will probably jump out to everybody, but would you tell everybody kind of what the tattoo on your forearm is?
That's my name in Star Wars language. That's Chris, and the language called Arubesh. So it is spelled in a bunch of funny looking characters, but you're going to pronounce it the same way you would American English.
Awesome. Chris has a second Star Wars tattoo of the Mandalorian sigil as well. All right. Let's jump into our science here. So the first topic is traveling at light speed. Each different section is going to start with 2 to 4 trivia questions. So please just type your guesses in the chat. There's no scorekeeping here. It's not for points. You know, it's like whose line is it anyway? The points are made up, and there's no prizes. All right. So the first question that I'm going to show here in a second is going to be a test question, just to give everybody a sense of how this will work, and then we'll kind of move on to more topical questions after that. All right. So, and Chris, you and I, we can alternate taking questions. So I'll take this first one, and then you can jump in. So the first question is, do you like sand? You know, it's and just if anybody wants to type their guesses, you can just type your number in the chat on what you think the correct answer is. And I'll just give everybody 10, 15 seconds, and then we can jump on to the next one. All right, excellent. So this was actually a trick question that we're starting with. They're all correct answers. This is a terrible line of dialogue from Attack of the Clones where Anakin is complaining about sand. It gets heavily memed. So now we're gonna jump into our real questions. All right, Chris, do you want to take this one?
Yes. Which ship is the fastest in the Rebel fleet? 1, Millennium Falcon. 2, X-Wing. 3, A-Wing. Or 4, Y-Wing.
I should also jump and say, if we're being pedantic, which we are, I'm asking about which ship is the fastest at light speed, not sublight speeds.
Okay. So they're putting their answers right now still, yeah?
Yeah, we're getting a couple dropped in the chat right now.
Okay.
We'll give it just 10 more seconds.
I'm driving home from the gym, everyone, so I'm multitasking. But don't worry, the force is with me.
All right, be careful in there. All right, Chris, give us our answer.
Answer is number 1, Millennium Falcon.
Yes. Can you give us any information there about the hyperdrive of the Millennium Falcon, or any faster ships that you may know of from your extensive knowledge of Star Wars lore?
Well, the Millennium Falcon is a Carillion freighter, a YT 1300 it should be, and it was originally owned by everyone's favorite businessman and smuggler, Lando Calrissian. You guys saw the movie Star Wars Solo, and you can get some of the background on the Millennium Falcon. But Han Solo is the guy who won that ship in a gambling game of chance, I believe it was, and he is the owner of the Millennium Falcon all the way up until Star Wars Episode 7, The Force Awakens.
All right, awesome, thank you. Let's jump on. I'll take this next question here. So this is a real, science question based in our universe here. How fast is the speed of light? 1, 670,616,629 miles per hour. 2, 238,900 miles per hour. 3, 767 miles per hour. Or 4, 23,781,963,008 miles per hour.
I'm curious. I want to know.
I guess I should make the timer a little bit shorter so people aren't having a chance to Google, but because there's no prizes, there's not really an incentive to cheat anyway. All right, you have 5 more seconds here. And do it. So the correct answer was 1, 670,616,629 miles per hour. We're going to be discussing the speed a whole lot more as we progress here through our light speed section. And I think we have 1 or 2 more questions. So, Chris, are you able to do this one while you drive? If not, I'm happy to take it.
Yes. How long does it take light from the sun to reach Earth? 1, 1 hour. 2, 8 minutes, 20 seconds. 3, 6 seconds. Or 4, 12 minutes and 40 seconds. What do you guys think that answer is? I think I know the answer. Not gonna say
What's
it
your guess,
though,
Chris? So Chris has not like really gone through these slides comprehensively. So if you want to shout your guess out, Chris, please.
I'm gonna go with 2.
Okay.
8 minutes and 20 seconds.
I see we've got another 2 in the chat as well. All right. And Chris, and it looks like Steve, you guys are both correct. It's 8 minutes and 20 seconds. So light leaving the sun takes a little over 8 minutes on average to reach us here on Earth. If you guessed the 12 minutes and 40 seconds, that's actually how long it takes traveling at the speed of light it would take to go from Earth to Mars. All right. Yeah. And now we're done with our trivia aspect for this portion of the presentation. There will be more later. So now let's do traveling at light speed for real. So how fast are humans right now? So the speed record for human beings was set 52 years ago in 1969 on the Apollo 10 mission. The Apollo 10 astronauts, as they were re-entering the Earth's orbit, were going about 24,816 miles per hour, which is insane. I mean, if Chris is driving fast right now, he's going 60, 70, 80 miles per hour. Hopefully he's not voice presenting, but that would be, fast for us here. So these people were going 24,000 miles per hour. But 24,000 miles per hour is still only 0.00003% of the speed of light, or 3/1000ths of the speed of light. And here's a fun connection. This doesn't really have to do with the speed of light, but an Apollo connection to Star Wars. Ron Howard directed Apollo 13, and 25 years later, his daughter Bryce Dallas Howard directed an episode of The Mandalorian. And so in Bryce Dallas Howard's episode of The Mandalorian, she created a little homage to the Apollo 13 movie her father directed. This is a really quick, short clip. It's like 15 seconds. So pay attention here. Okay. I just thought that was a nice little connection between The Mandalorian and the Apollo program, even though it's technically a movie.
Ron Howard also directed Solo.
He did. Good point. I totally forgot about that. All right. So following up, how fast are humans now? So the fastest man-made craft ever is currently is the Parker Solar Probe. This is a mission that is ongoing right now. In 2018, the Parker Solar Probe became the fastest man-made object, going 153,000 miles per hour. This probe is going to continue to break its own speed record on its way to the sun. And once it gets to the sun, it is actually going to round the sun, and the gravity from the sun is going to accelerate it to about 430,000 miles per hour, which is insanely fast. It's double the speed of the Apollo 10 mission. However, again, 430,000 miles per hour is only 0.00006 or 6/1000ths of the speed of light, which is 670 million miles per hour. So while we are getting very fast as human beings, we are still not even a fraction of the speed of light. So even to pile on with this bad news. Even if we could travel at the speed of light in our galaxy, the distance between objects is just insanely far. So if we could travel at the speed of light, it would take us, as I said earlier, it would take us about 12 minutes to get to Mars, or a car ride out to your local grocery store. If we could travel at the speed of light, it would take about a little over 4 hours to get to Neptune, or, the distance from Evergreen Park to St. Louis. But Neptune, I should say, is the 8th planet in our solar system. It is the farthest planet in our solar system. So you could travel up basically our whole solar system in about, a little over 4 hours. But if you wanted to go to the closest star to our sun, which is the star Proxima Centauri, you would have to travel at light speed for over 4 years. So if you wanted to take a vacation to Proxima Centauri, you would travel 4.5 years there, spend your week vacation, and then 4.5 years back. That would be spending a whole decade for one vacation with that travel time. If you wanted to travel from the Earth to the other side of our own Milky Way galaxy, it would take 52,000 years traveling at light speed. And then if you wanted to go to the closest galaxy to our Milky Way galaxy, it would take over 2.5 million years. So, traveling at light speed is just, these distances are just insurmountable for human beings to do in a lifetime. So when they say that they're traveling at light speed in Star Wars, what they probably mean is that they are traveling faster than light speed. First we'll talk about, a theoretical way for humans to maybe go light speed one day, and then we'll talk about what we would need to do, which is go faster than light speed. So electromagnetic fields. Electromagnetic fields are the same principle that holds magnets on your fridge. They can be used to accelerate particles. And so in Sweden, the CERN laboratory has built the Large Hadron Collider. And this collider, which is built by humans, it's operating now in Sweden, accelerates protons to 99.9% the speed of light. So that is something we've built now that can accelerate things to the speed of light. And there are theoretical concepts of how this could be implemented to do, space travel. But really the big issue right now is that this system only works on objects that don't have mass or have an extremely, extremely small mass, like, a single proton. If we wanted to use this technology to accelerate, say, a spaceship, it would take almost all of the energy in the known universe to make that happen, which is, let's say it's not realistic right now, but it is cool that we kind of have some components that could one day ladder up into, light speed travel. Now I'm going to talk about going faster than light travel. 2 weeks ago, a couple papers were published about mathematical concepts of how warp drives could be possible. So I'm going to show a couple minutes of 2 videos here, and then we'll come back to Chris and I presenting.
That Einstein guy was a real bummer for our hopes of a star-hopping science fiction-y future. His whole nothing travels faster than light thing seems to ensure that exploration of even the local part of our galaxy will be an excruciatingly slow affair. But Einstein also gave us a glimmer of hope. He showed us that space and time can be warped. And so the warp drive was conceived. Just recently, a couple of papers contend that this is not pure science fiction. In 1915, Albert Einstein's general theory of relativity revealed that the fabric of space and time is mutable and dynamic. It can, in fact, be warped. You can't travel through space at faster than the speed of light, but there's no speed limit for the fabric of space itself. This hints at a possibility for faster than light or superluminal travel. And only 15 years after general relativity's debut, the warp drive was invented, propelling humanity on its first journeys to the stars. That invention and those journeys were in the 1931 spring edition of Amazing Stories. In Islands of Space, its author, John Campbell, talks about increasing the cosmic speed limit by curving the fabric of space. The idea caught on. According to the wonderful Historical Dictionary of Science Fiction, the first mention of a space warp as a propulsion mechanism was in J. Williamson's 1936 story, The Cometeers. Space warp drives, time warp drives, and eventually just warp drives became an increasingly popular way of breaking Einstein's rules. The pretend technology really took off with Star Trek in the 60s, and Star Trek inspired the very first real warp-filled solution to the Einstein field equations of general relativity. That's the Alcubierre warp field derived by Mexican physicist and Star Trek aficionado Miguel Alcubierre. Now, we covered Alcubierre's idea a few years ago. Back then, the warp field solution looked like a very carefully calculated work of pure fiction. It broke the laws of physics in ways that I will come back to. Subsequent studies have tried to fix this, and a very recent paper claims to have solved the worst deal breaker in Alcubierre's proposal. Today, we're going to pull apart 2 new papers on warp drives and see if it's really time to don our Star Trek cosplay and warp out of here. Before we get to the new work, let's talk light speed and warp drives. Einstein's speed limit doesn't directly say that nothing can travel faster than light. His special theory of relativity just says that it takes infinite energy to accelerate anything with positive mass all the way to light speed. That effectively means that it's impossible to observe a massive object cross this speed barrier. But there are loopholes. In certain circumstances, we can think of space itself as moving, and there's no limit to the relative motion of 2 patches of space. And so objects in these patches could have superluminal speeds relative to each other. For example, inside black holes, we can think of space as flowing downwards faster than light, or beyond the cosmic horizon, the expanding universe is carrying galaxies away from us faster than light. The warp drive takes advantage of this loophole by accelerating a patch of space relative to its surroundings. Objects in that warp bubble move with that patch without themselves ever feeling any acceleration. This is what the Alcubierre drive is supposed to do. It's a space-time geometry that's a valid solution to the equations of general relativity, the Einstein field equations. It includes a comfortable flat region of space surrounded by a region of extreme spatial curvature. The space behind this bubble is expanded while the space in front is contracted. The resulting push-pull propels the bubble and any spaceship that it contains. The Alcubierre warp field may be a valid solution to the Einstein field equations, but that doesn't mean that it's physically possible. That Einstein guy was a real bum.
Okay, and then that is a pretty complex topic. So I also have just 1 more minute of Susan Hassenfelder, who is going to fill us in on just a little bit more of how warp drive might work.
Mike, I just want to say real quick that
yeah, go ahead.
Star Wars is cooler than Star Trek. I know that guy mentioned Star Trek, but I just got to throw that in there real quick.
Thank you for jumping in, Chris. I actually typed out in the chat, I said, I apologize for the Star Trek references, everyone. Yeah, I recognize that happens. And so Sabine Hassenfelder, her video here actually starts with an X-Wing, but I don't want to spend too much time on videos, so I'm just going to jump to the relative stuff. But thank you for saying that, Chris, in case people aren't able to see the chats. Yeah, this is strictly a Star Wars presentation, you guys. I'm really sorry that happened.
Warp drive spacetime. The warp drive geometry is basically a bubble. It has an inside region, which they call the passenger area. In the passenger area, spacetime is flat, so there are no gravitational forces. Then the warp drive has a wall of some sort of material that surrounds the passenger area. And then it has an outside region. This outside region has the gravitational field of the warp drive itself, but the gravitational field falls off, and in the far distance one has normal flat spacetime. This is important so you can embed the solution into our actual universe. What makes this fairly general construction a warp drive is that the passage of time inside of the passenger area can be different from that outside of it. That's what you need if you have normal objects like your warp drive passengers and want to move them faster than the speed of light. You cannot break the speed of light barrier for the passengers themselves relative to space-time. So instead, you keep them moving normally in the bubble, but then you move the bubble itself superluminally. As I explained earlier, the relevant question is then, what does the wall of the passenger area have to be made of? Is this a physically possible distribution of mass and energy? Bobrick and Martire explain that if you want superluminal motion, you need negative energy densities. If you want acceleration, you need to feed energy and momentum into the system. And the only reason the Alcubierre drive moves faster than the speed of light is that one simply assumed it does. Suddenly it all makes sense. I really like this new paper because to me it has really demystified warp drives. Now, you may find this somewhat of a downer because really it says that we still don't know how to accelerate to superluminal speeds. But I think this is a big step forward because now we have a much better mathematical basis to study warp drives.
Okay, awesome. So what Susan Hassenfelder is saying there is that, in theory, a warp drive that bends or warps the space around a ship to move that ship faster than light could be possible. Two papers were published just 2 weeks ago by a reputable journal of astrophysics, kind of discussing the mathematical concepts and how they could work. However, there are still, extremely significant barriers to this becoming a real thing. And first and foremost is the energy source. It would require harnessing like dark energy to power this vehicle, which is something that we only have the slightest of understandings of at this time, let alone how it would possibly work to harness it. But I do think that it's really cool, that astrophysicists are spending their time and energy, thinking about things like this. And so before, we go too far down the rabbit hole here on theoretical concepts, I'm going to move on. But Chris, do you know of any? Obviously in Star Wars they use warp drives to power their ships. Are there any other like power sources for space travel in Star Wars that you know of?
In Star Wars, there was this group of aliens named the Yuuzhan Vong, and they didn't like technology at all, but they had a sentient species which could pretty much make a black hole, and that black hole was pretty much like a portal to get from one point in space to another. So it was like technology, but not technology. They weren't moving faster than light the way that we've been discussing, but they would create a black hole, which is just a singularity. And they'd go from one point in space to another location.
That's super cool. Again, you guys, I did not prep Chris on this at all. He was just jumping and he just actually knows this much about Star Wars. But what's cool too, I don't have anything in the presentation about this, but that is another theoretical way to like travel, is to like use black holes in that way. I'm not qualified to talk about that right now, or it's not. Also, if anybody has seen Star Wars Rebels, there are like, I don't know what the species is called, but they're like these space whales that, like you said, like are an organic, creature that is capable of traveling at light speed.
Yep. I just looked at that episode last week.
That's awesome. All right, let's keep it moving here. All right, that's going to keep happening with videos, I think, as I try to move off those slides. All right, our next section, planetary possibilities, and we are going to resume with some trivia here. Chris, would you like to take our first question here?
Sure. It says, which of these planets is Hoth? So you got 3 options there. Go ahead, put your best guess in the chat.
This will be a quick one, I think.
Yeah, I think everyone should get this right.
All right, we got a guess for number 3. Got 2 guesses for 3. Oh, 3 guesses for 3. I'll give 5 more seconds here.
Which one do you think it is, Mike?
So I made this question, so this probably isn't fair for me to answer. Do you have a guess, Chris? I mean, you probably have an inside track too with your encyclopedic knowledge of Star Wars, but what would you guess?
I have a strong feeling that it's 2.
All right.
1 and 3 look like gas giants to me, but I could be wrong. Let's find out.
So the first half of your assertion was correct. So the correct answer is number 2, Hoth. 1 and 3 are planets in our solar system, and they're actually ice giants. So they're made of like a physical mass rather than a gaseous state. But yeah, number 2, Hoth. Fun fact. All 3 of these planets were visited by spaceships in the 1980s. So the Neptune and Uranus have only been visited by spacecraft 1 time, and that was the Voyager 2 spacecraft. It flew by Uranus in 1986 and Neptune in 1989. And of course, Hoth was visited by the Empire Star Destroyers in 1980 when The Empire Strikes Back came to theaters. All right, let's move on to our next question. How cold is Neptune? So your answers are 1, -459 degrees Fahrenheit, 2, -120 degrees Fahrenheit, 3, -80 degrees Fahrenheit, and 4, negative 392 degrees Fahrenheit. If we can get a couple guesses, we'll keep it moving. All right, got a couple guesses for 1. Got a guess for 3. 4. All right, great answer, Steve. I'm probably pronouncing your name wrong because it's a username, but the correct answer is, in fact, number 4, negative 392 degrees Fahrenheit. This is just because Neptune is 30 times farther away from our sun than the Earth is. And so very little light and heat reaches it that far out in space. The third answer was actually negative 80 degrees Fahrenheit, which is the average temperature on Mars.
Okay.
Yeah. All right, Chris, we got one more question in this section. You want go ahead and take it.
Which of these planets is Earth? 1, 2, 3, or 4? I don't know. I think I'm gonna go with number 1. That looks like Earth to me. I'm gonna go with number 1.
Chris, do you recognize? So 3 of these planets are Star Wars planets, and one of them is actually Earth. Chris, do you recognize any of the Star Wars planets? Actually, wait. Don't answer that. Once everybody's guesses are in, we'll have you try and guess which planet is which Star Wars planet. See if you can do that.
Right. Gotcha. I see at least 2 that I'm pretty sure about. I don't know.
Okay, we've got a lot of guesses in here. We've got several for 3, a couple for 2. Chris, why don't you give us your guesses on which is which?
I think number 1 is from The Force Awakens. That looks like Taco Dana. Number 2, I feel like number 2 is Naboo, but I could be wrong. But it looks kind of like Naboo. 4, I'm not sure.
All right. Let's move on. And here are answers. The correct answer was number 3 is Earth. Yep. All right. And I'm now second guessing myself because we had a couple people say that 4 could have been, Alderaan, and 2 could have been Naboo. I might have to fact check myself at the end of this presentation, make sure that I subtitled those planets correctly. But yes, the correct answer is number 3.
They look so similar.
This picture of Earth was actually taken on the Apollo 17 mission 50 years ago. So humans have been to the moon 6 times, and the Apollo 17 mission 50 years ago was actually the last time that humans were on the moon. There are actually currently plans, though, to put humans back on the moon by NASA in 2024. So let's keep it moving. Oh, shoot, there's one more. Chris, you're on again.
Which planet does Anakin Skywalker lose his legs and his hair? LOL. Is it 1, Mustafar, 2, Camino, 3, Coruscant, or 4, Venus?
I guess he also loses one of his other arm there, some skin, his dignity, his wife,
his pride.
Yeah. All right, I got some answers. We got our answers are all over the place for this one. Several for 1, a couple for 3. We got 1 for 2. All right, Chris, let us know what it is.
I'm gonna go with number 1, Mustafar.
Yeah, you know it. All right, and in the movies, so Mustafar is briefly shown in Rogue One, a Star Wars story, and also briefly shown in Episode 9, Rise of Skywalker. But it kind of looks like it's cooled off some in those movies. Do you have any idea why that happens in the movies, like the canon universe explanation?
Yeah, so it's going through a process pretty much that Earth went through a long, long time ago. It's starting off as a volcanic planet, but the volcano, or the volcanic activity, I should say, is calming down. And so the lava is turning into layers of rock. And over time, like you said, in Episode 9, Rise of Skywalker, you're actually seeing less lava. You're seeing less of that activity, and it's cooling down and turning into what will one day be a planet that will probably look like Earth.
Wow, I honestly didn't know that at all. We got kind of a fun, science side out of it. There's even trees starting to come up through the rock and sit in Rise of Skywalker. So
exactly,
yeah. I had no idea why that was happening. That's awesome. All right. Here's another fun Star Wars prequel meme. I don't know if anybody here uses Reddit, but this is still one from Reddit prequel memes. And so this is an actual scene from the movies where Anakin is complaining about not getting to be a Jedi Master, but reframed for how Pluto would be treated in this situation.
That's a good one.
Thank you. I thought it was perfect for this presentation. I giggled a little bit. All right, so we're going to talk about 3 planets now that exist in Star Wars, and some similarities between these and planets here in our universe. First one is obviously Tatooine. It's a harsh desert environment. There's sandstorms and dune seas, and it orbits 2 suns rather than 1 sun. Which about half of all exoplanets in our real universe orbit 2 suns, 2 or more suns. So it's pretty cool that this is actually a possibility, that there could be real exoplanets out there orbiting 2 or more suns that are in a habitable zone that could sustain life. Chris, do you have anything to add about Tatooine's climate or geography? Because I don't.
Tatooine, if
Yeah.
people can recall, it's a desert planet, and it's like that because there's 2 suns. But binary star systems are actually real. They're all over, like you said, they're all over our galaxy. Tatooine is so hot because there's 2 suns. If there was only 1 sun, Tatooine wouldn't be in what's called the habitable zone, which is a distance from the planet or from the sun that a planet needs to be to have life. So Tatooine is in the habitable zone because there's 2 suns, but those 2 suns make it really, really hot.
Yeah, absolutely. And so here, as I move forward, here's an example of a real exoplanet in our universe. It's called Kepler 453b, which is not the most fun name, but it orbits 2 stars. And so Kepler 453b itself is actually a gas giant, kind of like Jupiter or Saturn. But when planets are that big, when they're gas giants, they generally have moons, and lots of moons. And so those moons would also be in the habitable zone from these stars. So that habitable zone means that it is a distance from the stars where it's not too hot, not too cold. Water could exist in its liquid form, and it could sustain life. And so it's cool that there are exoplanets like Kepler 453b that could be habitable and orbit 2 suns, just like Tatooine. And if we're going to talk about, looking for a desert world, we should obviously talk about Mars. This image is from the Perseverance rover, which landed on Mars just a couple months ago. And if that doesn't look like the Dune Sea, I don't know what does. The catch is that Mars is quite a bit colder than Tatooine. Like I said earlier, it averages about -80 degrees Fahrenheit. And the atmosphere is 96% carbon dioxide. So it wouldn't be inhabitable to human life as the way Tatooine is portrayed in the movies. I do want to show you guys, I think this is really cool though. There's a Twitter account for the Perseverance rover where they kind of share videos and pictures and sounds that it's capturing on its mission. And here you can see a video. So the Perseverance rover is a robot, and it is taking a video of another robot. It's a helicopter called the Ingenuity helicopter. So this is on Mars. This is on a different planet. We have one robot taking a video of another robot that is flying. I think that is so cool. It just makes me think man, how much longer will it be until the Perseverance rover in this scenario is R2-D2 and the Ingenuity helicopter, is Luke Skywalker and his T-16 Skyhopper, taking off. I just think it's so cool that we are already doing things like this on other planets. It just makes Star Wars feel that much, closer to us. All right, I'm going to pop back into the presentation now. And here's the last image before that rover went offline. This is obviously a joke. There are not Jawas that we know of on Mars. All right, now we're on to Mustafar. This is the scene of that epic duel between Obi-Wan and Anakin in Revenge of the Sith. It's covered in lava in that movie. By the time we get to Rise of Skywalker, it's cooled off, as Chris just explained to us. So let's talk about some real world analogies in our own solar system. The first one is actually a moon of Jupiter. So remember I talked about how gas giants generally have lots of moons. Io is one of those moons. Io is the most geologically active object in our entire solar system. It has 400 active volcanoes, which is just insane. because it's so far away from the sun, the general temperature is about, average temperature is about negative 200 degrees Fahrenheit. But at those volcanoes, it can reach 3,000 degrees Fahrenheit, which is, unfortunately, these volcanoes don't erupt, lava and look cool like Mustafar. Instead, they're erupting with sulfur, so they probably smell like rotten eggs or toots, which is, probably wouldn't be too fun to visit. All right, and then another analogy, kind of in our own solar system, is Venus. Even though Venus is not the closest planet to the sun, it is still the hottest. It's the second closest. Mercury is the closest planet to the sun. Venus has a thick atmosphere full of greenhouse gases like carbon dioxide, and it has clouds made of sulfuric acid. So when that sunlight and heat get onto Venus, they get trapped by those clouds and gases and just stay there, which means that Venus on averages 880 degrees Fahrenheit. Which is insane. It also has tens of thousands of volcanoes. Not all of them are active, which is why it's not considered as geologically active as Io. But just the fact that it has tens of thousands of volcanoes is wild. And even the planet itself kind of looks like Mustafar from images like this. So I think that's pretty cool. All right, we have one more planet to go through in this section, and that planet is Hoth. Here we have a little GIF zooming in on, I think, Luke on his tauntaun. All right, so this is a super cool. Chris, do you have any information you can give us about like the climate or geography of Hoth or anything else? Because I don't, you're the expert here. I'll defer to you.
Well, the one tongue-in-cheek thing about Star Wars planets is that the biodiversity and the terrain, like the geology, is all the same. There's no variance, unfortunately, and which is kind of, I don't think, Mike, we'd see too much of that in reality, but it's Star Wars. So Hoth is an entire planet that's just ice. And then we spoke about Mustafar, an entire planet that's just volcanoes. And then you got Tatooine, an entire planet that's just desert. So Hoth is just a big frozen ball. And I think if it was just a big frozen ball, it'd probably be kind of hard for humans and other organisms to live there. But that's what we get with Hoth. It's a big old Chicago in January type of place.
Chris, off the top of your head, do you know where they filmed the Hoth scenes here on Earth?
I believe they went to Sweden.
Okay, Sweden. Okay, yeah, that's it's beautiful and also terrifying how cold it looks.
Yeah.
All right, let's move on to some similar planets. Well, not similar, but comparable planets here in our solar system. Here are the two ice giants we talked about, Uranus and Neptune. I giggled a little bit when I was doing lots of research on Uranus. But all right, Uranus averages negative 325 degrees Fahrenheit. It is an ice giant and it has 27 moons. In my research for this presentation, I found that Hoth actually only has 3 moons. So Uranus has many more than that. And it is given its blue color because it is, trying to remember what gases it has. It's got 3 different kinds of gas. And so you'll notice it's like a lighter blue color than Neptune. So Neptune, has like ammonia, water, methane gases on it. And I think that Neptune or Uranus just has like more methane, which is what gives it that lighter blue color. All right, so Neptune averages, negative 350 degrees Fahrenheit. It's also an ice giant. It's actually 1 billion miles farther than Uranus. It's almost double the distance of Uranus from the sun, which is crazy how much farther out it is. It's actually the first planet that we found, I believe, using math rather than telescopes. So somebody wasn't just looking through a telescope one night and noticed that one of those stars seemed to be moving. It was actually found just through it's so far away and it's not visible with the naked eye. So it was actually found through using just calculations based on how the planets pulled each other with their own gravity. All right, let's keep it moving. So now we're on to our last section here, which is Death Star physics. So we are going to do 2 more trivia questions, I believe, and then talk about kind of what it would take to actually blow up a planet. All right, Chris, you're on. Take us through these last two questions.
All right, what powers the Death Star's Superlaser? Is it 1, twin ion engines, 2, Kyber crystals, 3, class 0.5 hyperdrive, or 4, it absorbs stars? What powers the Death Star's Superlaser?
Got a couple of guesses for 2 right now. I'll give it a 10 more seconds. Got a guess for 1. One for 3, another one for 2. All right, we've had several guesses for 2. Chris, you want to give us the correct answer?
Yes, the answer is 2, Kyber crystals.
All right, good job. I think we had the majority of our people get that one.
Yep.
So the Death Star actually uses 8 Kyber crystals, which are like, also what powers. Well, Chris, you want to tell us a little bit about like Kyber crystals? What gives them their color? For everybody's context, Kyber crystals are also what power Jedi's lightsabers and give the blade their color. Can you tell us why they're different colors? Do you have any insight into that?
Just naturally forming, just the same way that crystals here on Earth can be different colors. Kyber crystals are naturally forming, and they have different colors as well. Another type of crystal that Jedi use for their lightsaber is Ilum crystals, but the Kyber crystals were a bit more common. And the main bad guy in all of Star Wars, Darth Sidious, he also had a lightsaber at one point, so he knew the power that Kyber crystals had. And unfortunately, he used that for some very bad things, like building a Death Star, 2 of them actually.
Yeah. All right. So let's keep moving here. This is actually a screenshot from Star Wars Rebels. They are working to stop the Empire from getting the Kyber crystals for building the Death Star, and they thwarted them a couple times. Obviously, not enough. All right, we have another question here. Go for it, Chris.
How many moons does Mars have? 1, 2, 3, or 4? That's a good question.
I should say so. For context, I thought of this question because in Star Wars Episode 4, both Luke and Han mistake the Death Star for being a small moon. And so Mars has, at least one moon, and it has the smallest moon in our known moon in our entire solar system. It has a moon that's under 8 miles wide. And for context, our own moon here on Earth is over 2,000 miles wide, and this one is less than 8 miles wide. So we've got a couple guesses in the chat. Looks like we've got a 2, guess for 2, a guess for 1, a guess for 3. We're all over the board on this one. And the answer is actually 2. It has 2 moons. Yeah. Phobos. Yeah, Phobos and Deimos. So Deimos is the smallest moon and known moon in our solar system. It's less than 8 miles wide, and Phobos is about twice that size. It's about 14 miles wide.
Wow. I know Phobos is in Greek mythology the son of Ares, the god of war. Phobos was the god of fear. It's a little.
And that's fun. So yeah, and so in Greek mythology, Ares, the god of war, is named Mars when the Romans kind of co-opt that religion and kind of just take the same religion but change the names of the gods. So it's fun that the god of war Mars is orbited by his son Phobos.
That's nice. Would you happen to know the largest moon in our solar system, Mike? I'm just curious. I have a guess, but
I don't know it off the top of my head. I would guess that it is one of the moons orbiting Jupiter.
Yeah.
Yes.
I think it's Titan, but I could be wrong.
Titan would be my guess as well without fact checking myself.
Okay.
So there are 4 moons that Galileo spotted in the early 1600s. They're called the Galilean moons. They're so big that, a telescope in the 1600s could see them. So to see a moon orbiting a planet that far away is just insane, especially by the technology we had in the early 1600s. So those moons are all clearly very big moons to be able to be seen with that technology. And I know that Titan is among the biggest of them. So, there it is. Somebody just Googled it. Thank you, Patty. It's Ganymede, a moon of Jupiter. So it is one of the Jupiter moons. It's probably one of the Galilean moons. And it's larger than one of our planets. Thank you, Patty. I'm glad that we're crowdsourcing this information. This is great. All right. Let's keep it going. All right. So now we're on to the physics of blowing up planets. So I'm going to show a clip here for a second that I'm sure we have all probably seen if we're here on this this presentation, but it's only 10 seconds, so let's do it anyway.
Commence primary ignition.
Okay, so I want everyone to think about this for a minute. You know, a battle station the size of a moon with kyber crystals as its source is able to destroy an entire planet of Alderaan, which is, I looked it up on Wikipedia. Alderaan is about the size of Earth. So this small moon station is able to destroy an entire planet the size of Earth in less than 3 seconds, just a matter of seconds. Also, if you're looking closely there, when they fire the Death Star, you can see 8 small beams kind of go from around that dish and then meet in the center to fire one large beam. Each of those 8 beams is from one of the 8 kyber crystals powering the Death Star.
Hey.
So now we're going to move on to one more. Okay, so Alderaan, Earth-sized. It's held together by the force of gravity. And we know that, what it takes to hold Earth together based on its material and its size. It's 2.24 times 10 to the 32 joules of energy is what it would take to destroy the Earth, because that is the amount of force holding it together. Here is another video from Star Wars The Force Awakens of the Starkiller base, which is another super laser weapon, charging itself up by absorbing a sun.
Begin charging the weapon.
Yes, sir. Weapon charging.
Okay, so as you can see there, Starkiller base absorbing a sun to use that to blow up a planet, or actually, in this case, 5 planets. So our sun has a total power output of, so if you could harness the entire energy of the sun, obviously it's shooting light and energy in all sorts of directions, but if you could harness that and aim it into one beam in one direction, the total power output is about 3.8 times 10 to the 26th joules, which is much smaller than 10 to the 32nd joules, which it's actually a factor of, 100 million less than the energy needed to destroy a planet like Alderaan. So a weapon firing the power of our sun would actually take a full week to destroy Alderaan, or our sun would take a full week to destroy the Earth. What this means is that, Star Wars is a series that loves its super lasers, and it means that each of these super laser weapons is carrying the power of hundreds of millions of suns, because they have the ability to fire over and over and have these impacts over and over. Sorry, Chris, you were going to say something. What were we going to jump in and say there?
No, I was just chuckling. Like, super lasers are a huge part of Star Wars. Like, wow, they really like to blow stuff up.
Yeah, I mean, from the first Death Star to the second Death Star to the Starkiller base to the entire Sith fleet. Is that what it's called? Is it called the Sith fleet? All the Star Destroyers and the Rise of Skywalker?
The Final Order.
Final Order. Okay. Yeah, so every ship in the Final Order, has the power of hundreds of millions of suns, which is like very silly, but also, that's a daunting enemy. So this is actually takes us to the end of our presentation, everyone. Like as Han Solo would say, facing the power of hundreds of millions of suns, never tell me the odds. And with that, I'll leave you guys to hopefully go watch a Star Wars movie to cap off this May the 4th celebration. Does anyone have any questions or comments they'd like to make? Yeah, feel free to unmute and jump in.
This is Julie. I can you hear me?
Yes.
Okay. I really have nothing to ask, nothing to say, because this was so beyond me. But I would like to thank you and Chris. I admire your enthusiasm and your knowledge. Unbelievable.
Thank you.
Yeah.
Thank you.
Yeah.
Thank you. So
we always knew that this encyclopedic knowledge of Star Wars was going to come in handy.
thank you
cool.
so much.
Yeah, thank you everyone for attending. I really appreciate everyone being here. This has been really great.
Appreciate it, guys.
Yeah, thanks for jumping on the chat. That made it a lot of fun. And cool. With that, I'm gonna close the call then. All right. Thank you, everyone.
Thank you.
Yes, thank you.
Yeah.
Great.
Yep. Bye. Stop.